So today we're going to be working on applications of systems. And so we're still solving systems using substitution and elimination. The only difference is we're going to be writing the equations that we're going to be solving to actually answer a question. So let's go ahead and get started here with this first application. At Kohl's, Sue bought 3 t-shirts and 4 dress shirts for $84. Tammy bought 2 t-shirts and 2 dress shirts for $46. So what is the price of 1 dress shirt? So we're going to start with writing our equations. So we're going to start with writing an equation for Sue and defining our variables. So I'm going to let the t-shirts be X and the dress shirts be Y. And so if Sue bought 3 t-shirts, that's 3 X's. She also bought 4 dress shirts, that's 4 Y's, for a total of $84. $84. And then we can then write an equation for Tammy. Tammy bought 2 t-shirts, that's 2 X's, and she bought 2 dress shirts, that's 2 Y's, for a total of $46. And what we're going to have to find is how much is a t-shirt and a dress shirt. So we're going to solve that for X and Y. So if we look at this and try to figure out what we're going to do to solve this using substitution or elimination, both will work. However, I'm going to try to eliminate the y's. We have a 4y on the top equation, and if I take this second equation and multiply it times -2, then this y is going to be a -2y. So if I do that with the whole thing, it's going to be -4x, 2x becomes -4x, 2y becomes -4y, and 46 becomes -92. And then I'm going to add this equation with this equation. So 3x and -4x is -x. My y's cancel. And a -92 and a +84, those add up to be a -8. So if -x is -8, that means +x is +8, which means that x, which is our t-shirts, the t-shirts cost $8. But they want to know what is the cost of a dress shirt. And so I'm going to have to figure out what y is. I'm going to use the equation that I circled over here. It's 2x, but that's 2 times 8. That's 16 plus 2y equals 46. So if I subtract 16 from both sides, then I'm going to have 2y equals 46 minus 16 is 30. Divided by 2, and y is 15. And so that means that a dress shirt is $15. And we would answer the question by labeling our answer as $15. And that would be the answer to this application question. We couldn't have answered this without knowing how to solve systems. So let's try another one. Here's number 2. We have 4 in this video. Paddling upstream, Joe can go 5 miles in 1 hour. However, paddling downstream, he can go 11 miles in 1 hour. How fast is the current of the stream? And so we have 2 currents here. I'm going to let X be how fast Joe can paddle. So Joe's speed by himself. And then I'm going to let Y be the speed of the current. The speed of the current. And so going upstream, that's going against the current. He can go 5 miles in an hour. And then paddling downstream, let's do this one first. Going downstream, he's paddling and the current's pushing him. He's going downstream. That means his speed, which is x, plus the speed of the current, that's x plus y, together is 11 miles per hour. However, if he switches it around and he's going in this direction and the current's going in the opposite direction, that means he's going upstream. That means it's his speed minus the speed of the current. He can go 5 miles per hour. So this is our system. And it'd be really easy to solve this system just by using elimination. If I add these together, x plus x is 2x, y plus a -y is nothing, they're eliminated, and 11 plus 5 is 16. And if I divide them both by 2, x is going to be 8. That means that Joe's speed by himself is 8 miles per hour. And then we can use, let's say we use this equation here. We know that x is 8, and so 8 plus y equals 11. So if I subtract 8 from both sides, y is 3. So that means that the speed of the current is 3 miles per hour. And the question that they asked us to solve is, how fast is the current of the stream? Well, that's 3 miles per hour. And we always want to make sure we go back, look at the question, and answer the question that they're asking us in the problem. So that's the second problem. Let's move on and take a look at number 3. It says Tim has a pocket full of nickels and dimes. He has a total of 36 coins worth a total of $2.90. How many nickels does he have? So there's our question. So I'm going to let N represent the number of nickels he has. But then he also has dimes. I'm going to let D represent the number of dimes that he has. And so in his pocket he has a total of 36 coins, and they're all nickels or dimes. So that means the number of nickels plus the number of dimes is equal to 36 altogether. But then we also know that each nickel is worth 5 cents. Also, we know that each dime is worth 10 cents. And the value of all of his change is 290 cents. Now I could have used 2.9, $2.90, but then this would have to be 0.05 and this would have to be 0.10. And I think it's just easier to say this is all in cents. 5 cents for each nickel, 10 cents for each dime, 290 cents is the same as $2, and 290 cents is the same thing as $2.90. So here we have our system. So again, I could use substitution here if I solve for this N or solve for this D pretty easily. Maybe I'll do that in this case. I'm going to get this N here by itself. I'm going to subtract D from both sides. So I'm going to have this equation. N is going to equal negative D plus 36. What I did is I just moved this D over to that side by subtracting D from both sides. Then I can take this right here and substitute negative D plus 36 in for this N. So it's going to look like this. We have 5 times negative D plus 36, because that's negative 5N, plus we have 10D equals 290. And now I'm going to solve this equation. If I distribute my 5 times negative D is negative 5D, plus 5 times 36 is 180, plus I have the 10D equals 290. So if I put my D's together, negative 5D plus 10D is 5D plus 180 equals 290. If I subtract 180 from both sides, I'll have 5D equals 290 minus 180 is 110. Divide by 5, and D is equal to 22, which means I have 22 dimes. But again, that's not the answer. The answer that they want to know is how many nickels do you have? So I'm going to use this equation here. I have N plus D, but D is 22, and that equals 36. So if I subtract 22 from both sides, my number of nickels is going to be 36 minus 22, which is 14 nickels. And so I want to make sure I go back and answer the question. It is 14 nickels. And I could, just to make sure I'm right, I could make sure that both of my equations are satisfied. 14 plus 22 is 36. And if I take 5 times my number of nickels, that's 5 times 14, that's 70 cents. 10 times 22 is $2.20. And if I add those together, I do have $2.90. So it makes both equations happy. Let's take a look at the last equation that we have in this video. Tyler decided to open his own business shoveling snow. It cost him $374 for his snowblower, as well as $3 per walk in gas. If he charges $20 per walk, how many walks will he need in order to break even? So we've done questions just like this before without systems. We just wrote one equation. But we can also solve these equations. With two equations, or this problem with two equations. We can write an equation for his profit, okay? So, and we can write an equation for his cost. So let's start with the one for his profit. We know that he gets $20 every time he shovels somebody's walk. So X represents the number of walks that he shovels, and Y is going to be money. In this case, the Y represents his profit. Now, if we write an equation for his cost, we know he's going to spend $3 for each walk in gas that he has to fill up with his snowblower. Plus, he also spent $374. $374. And so it's $3 for each fill up with his gas, plus it was $374 for his cost. So this represents his total cost. Every time he shovels a walk, the cost is going to increase. Every time he shovels a walk, his profit is going to increase. Well, this is going to be a really good equation to solve using substitution. If y is equal to 20x, I can substitute that in for this y here, and it's going to look like this. 20x, that's his profit. That's going to equal his cost, which is 3x plus 374. So we have solved this equation already just by writing the equation like this and just kind of not setting it up as a system. So, but now we can solve this for x. I can subtract 3x from both sides. And so if I do that, 20x minus 3x is going to be 17x, and that's going to equal 374. And then I'm going to divide by 17, and when I divide by 17, x is 22. And so the question was, how many walks will he need in order to break even? And so he's going to need to shovel 22 walks. And then his profit and his cost would end up being the same amount. And so there's how there's 4 examples of applications of systems. We're going to have many applications throughout this week that you're going to need to set up the equations and then solve for, and we will go over more of these in class.